Okay, hello everyone. Welcome to the Evolution of Wireless session, the most fun 45 minutes that you'll have at Discover. I promise. So I'm Wes Purvis.
My name is Pavan Jita, and this is probably one of the most viewed sessions that we had at the HP Vegas session, so we wanted to bring it here. And we're going to start, I guess, right now.
Yep. Okay, so of course the forward-looking statement slide, which I will skip past. From an agenda standpoint, the point of this session is to understand how we got to where we are right now in a wireless perspective, from Wi-Fi as well as cellular. So with that, let's get into it. So where does Wi-Fi come from? I'm going to start with kind of the foundation that many people may already know, and then kind of build up to where we are now. So from a Wi-Fi technology standpoint, it's the IEEE that is defining the standards, the technologies, so 802.11be, and then it is the Wi-Fi Alliance who is actually defining the Wi-Fi generation, right? And this is actually what gets deployed and the requirements that, to test interoperability. So if you think about, okay, IEEE 802.11be, this is the latest generation of Wi-Fi. We then have Wi-Fi Alliance who come and says, yeah, let me take all these Phi and MAC features. I might take some of them, not all of them that are defined by the IEEE, and then let's add in some security, and that is Wi-Fi 7. Then comes the vendors, that's us, and we say, hey, yeah, these are good. We're just going to kind of take this slice. So this is how we get to the features and functionality that we have in Wi-Fi. So if we start in the last 20 years, almost 30 years of Wi-Fi, we've really settled into a pace where every 3 years we have a new generation of Wi-Fi. If you go back to Wi-Fi 5, 2013, Wi-Fi 5, 11AC Wave 2, 2016, Wi-Fi 6, 2019, Wi-Fi 6E, 2022. Then we kind of had a half generation where Wi-Fi 6E to Wi-Fi 7 was actually only 2 years. But this kind of 3-year cycle is repeatable, and we expect that to continue going forward into new generations of Wi-Fi. We've also had some security changes over the past couple of years, and it was kind of slow, right? So 1997, Wi-Fi started with WEP. And then 1999, we got WPA2. 1999, we had WPA. 2004, we had WPA2, and that largely did not change for the next 14 or 15 years. Right? It wasn't until 2018 that we got WPA3. And at this point, the Wi-Fi Alliance realizes, hey, we really need to stay on top of the security game. And so WPA3 is built as a technology that evolves. It changes from year to year, and there's new requirements from year to year. That's why from Wi-Fi 6E, Wi-Fi 7, we have new security requirements, which I'll talk about. So just the highlights. I'm not going to go through everything in here. But kind of highlights, right? So we start with 802.11 prime, and we add in 11b, where it's 2.4 up to 11 megabits per second, and at the time, the most common Ethernet was 10 megabit, right? So Wi-Fi faster than Ethernet, not really, but that was the marketing. And then we continue with 11a and G, and that gets us up to the 54 megabits per second. 11n gave us MIMO. Kind of this is where I see the kind of the modern era of Wi-Fi, 802.11n in 2007, 2009 timeframe, where kind of things kind of picked up, and then we get into the newer generations, 11AC, 11AX, and 11BE, where we live today. So, kind of these are how I see some of the defining features of Wi-Fi. So one is channel bonding. This came in 802.11n. This is the ability to bond 2 or more channels together to have wider bandwidth, right? So the kind of default channel bandwidth in Wi-Fi is 20 megahertz. But 11n gave us 2 of those 20 megahertz channels bonded together, 40 megahertz. Now in Wi-Fi 7, we have 16 bonded channels. That's a 320 megahertz wide channel. Now there's not very many of those. You only get 1 of those in Europe. We get 3 in the US, where I'm from. But in the enterprise, we don't really use that kind of channel width, but it's possible, right? This is the easiest way to increase our throughput on Wi-Fi is by increasing the bandwidth that we're using. MIMO also came as part of Wi-Fi 5. This is multiple input, multiple output. So the ability to use multiple transmitters on an access point to transmit, and then multiple transmitters on a client to receive. Where in one spatial stream, we can transmit one set of data, so that would be like A, B, C. And then in the second spatial stream, we transmit a parallel stream of data, which is D, E, F. Right? And with that, we can, again, increase our throughput by using multiple spatial streams. And the notation that you'll see, like 4x4:4, that's 4 transmitters, 4 receivers, the number of spatial streams, 4 spatial streams. So from an access point perspective, most of the high-end access points are 4x4 with 4 spatial streams. The mid-tier may be 2x2 with 2 spatial streams, and most client devices these days are also 2x2. Another feature of Wi-Fi 5 was frame aggregation. So previous to this, every single frame that got transmitted over the air was transmitted and then acknowledged directly by the client, or vice versa. With 802.11n came frame aggregation, where multiple frames, a couple dozen frames, could be transmitted at once, and then the client can send back a block acknowledgement to acknowledge all of those frames at once. And this is another method that increased the throughput in Wi-Fi substantially. It made Wi-Fi more efficient, if you will. Then we get to Wi-Fi 6, Wi-Fi 6E. The big thing here was OFDMA. This is the ability for multiple users to use Wi-Fi simultaneously. Because previously, ignoring multi-user MIMO, I'm not even going to talk about it. Previously, with a normal OFDM transmission, it's like Wi-Fi is like a walkie-talkie, right? One person is transmitting at a time, and everybody else has to listen. With OFDMA, multiple users can access the channel at one time, where the access point is allocating different slices of bandwidth, different resource units, to different sets of clients. Wi-Fi 6E gave us the 6 gigahertz band. I maintain this is the most important feature of Wi-Fi in the last 10 years, and will continue to be even in the future, because it's additional bandwidth, additional spectrum, and that improves the throughput and usage of our deployments. In the EU and UK, we have about 500 megahertz of spectrum. That's about equivalent to how much spectrum is currently available on 5 gig. So we've basically doubled the amount of spectrum that Wi-Fi can use, which as usage increases, it's really important to have that extra bandwidth, because it improves the experience. It gives more capacity on the network. In the US, we're fortunate to have 1,200 megahertz of spectrum, 59 20 megahertz channels, and some other parts of the world. There's been some recent spectrum discussions in Europe, where some of the upper parts, the Uni 7 and Uni 8 bands in Europe, it's leaning towards the recommendation to allocate those to cellular, which is, in my opinion, unfortunate, but it's not set in stone yet. So today, what's available is the Uni 5 band in Europe. We're running 6 gigahertz at the conference. So if you're connected to the HPE Discover SSID, and your device is capable of 6 gigahertz, you're most likely connected on 6 gig. I think we're seeing very good 6 gigahertz adoption. And I think 6 gig has made a tremendous impact on our networks. So let's talk about Wi-Fi 7. This is where we are today, right? This is the modern. So the last 10 minutes is how we got to here. If you look on the internet, you will see a lot of different opinions, and even on Wi-Fi, you will. So in one case, this is a publication in the United States saying Wi-Fi 7 is here, but you don't need it. Other people are saying Wi-Fi 7 offers significant improvements. It'll change your life. I'm paraphrasing. But how do we have this disparity? What is it actually, right? So Wi-Fi 7 is the latest generation of Wi-Fi. We're very much in the still early days of Wi-Fi 7 deployments. However, I think we have begun our kind of mass deployments, right? We have lots of customers deploying Wi-Fi 7, and it's sort of the default deployment mode for at least for our net new customers. They're deploying Wi-Fi 7 and going down the Wi-Fi 7 journey. So here's kind of what we see from a adoption standpoint. So from a 6 gigahertz perspective, I'll start there because that's been out longer. We see about 60% of our 6 gigahertz capable access points actually have 6 gig enabled. So that means 40% of our customers who are buying Wi-Fi 6E access points have not actually enabled 6 gig. Now that's changed tremendously. If I look only at Wi-Fi 7 access points, that number is about 80% of people are enabling 6 gig. So we see a significant trend of people actually utilizing 6 gigahertz. I think there's a couple of stumbling blocks that people run across, and I'll talk about those a little bit later. From a client adoption standpoint, it really varies. So in environments where it's purely bring your own device, we may see in the 20, 30, 40% client adoption range. Over the weekend, I came from Las Vegas, another large conference, and their 6 gigahertz adoption was about 50%, right? So in the areas with 6 gigahertz, 50% clients connected on 5 gig, 50% connected on 6 gig, which is really, really encouraging, especially because on the 6 gigahertz band, you're more likely to be able to use wider channels, which improves the throughput for those clients. So Wi-Fi 6E has been out for about 3 years now. This is where we are from an adoption standpoint. Wi-Fi 7 is basically where Wi-Fi 6E was 3 years ago. So the client adoption is about 10%-ish. That will improve, that will increase over the years as Wi-Fi 7 gets deployed more and people refresh their client devices. Here's an example deployment from a live customer where they were in about 15% Wi-Fi 7 and about a third of their clients were connected on 6 gig. So what is Wi-Fi 7? What's in it? So there's both the PHY level features as well as the security features that Wi-Fi Alliance has brought in. So from a PHY and MAC perspective, we have increased modulation with 4K QAM, 320 megahertz wide channels, right? That's the 16 bonded channels. Multi-link operation, which is probably the most exciting feature of Wi-Fi 7. There's preamble puncturing, multi-resource unit, and increased aggregation using the 512 block hack. And I'll talk more about these. And then from a security perspective, Wi-Fi 7 brings some additional mandatory WPA3 security features, increases the encryption that's used to GCMP 256. There's different hashing used in WPA3 personal, as well as beacon protection to give some integrity to the beacons. If we look over the generations, right, so historically there was no new security things that were brought into the Wi-Fi generations. Right, so in Wi-Fi 6, you could use any security you wanted, WPA2, open, whatever it may be, TKIP if you really wanted to. Wi-Fi 6E introduced a requirement that you have to utilize WPA3 on the 6 gigahertz band. And that largely has gone well if you are deploying a WPA3 enterprise SSID. Even if you're deploying personal, but most people that we see start with their 802.1x SSID, turn on 6 gig. It's a very easy transition. From a Wi-Fi 7 perspective, there's now additional WPA3 requirements, as I mentioned on the last slide. So this is kind of the evolution, and I would expect as we get to Wi-Fi 8 and Wi-Fi 9 and other generations, we will continue to see security requirements tied to the Wi-Fi generation because it kind of improves our baseline of our security posture on Wi-Fi, which is a good thing, even though it may introduce some friction with client devices trying to keep up. So I spent the last 2 slides talking about, we have all this new security stuff, but let's talk about what happens in the real world. So this is a client. It's connected with 802.11be, so as Wi-Fi 7, and if you look at the security, it's labeled as WPA3 with CCMP. Now, CCMP is not allowed for a Wi-Fi 7 client. It should actually look like this with GCMP 256. But the point here is, I think both on the client side as well as the infrastructure side, we're a little bit laxed in terms of ensuring interoperability with the client devices, so that clients are actually connecting, which is I think a good thing, but it's technically outside of the scope of what Wi-Fi Alliance wants. From a adoption standpoint, here's what we see. If we look across deployments, about 50% of the deployments connection attempts that we see are on WPA2 personal. Right? That's a pre-shared key SSID. 1% WPA3 personal, just to put it in perspective. From a enterprise perspective, it's about 36% WPA2 and 9% WPA3 enterprise, with about 4% on OWE. This is a snapshot from October. This will continue to change and shift towards WPA3, but this is sort of the state of when we look across a broader customer base, what kind of security that we see. As well as we have been fortunate to have a customer that's deployed the same event year over year, and they've had a WPA3 personal transition SSID deployed since 2021, and that very first year, 80% of the clients connected with WPA3. That means 20% connected with WPA2. But starting 2022, that increased by 10% to 90%. 2023, 98%. 2024, 99.5%. And this is the event I came from over the weekend. This year, it's also at 99.5, 99.6%. So what this tells me is there is mass adoption of WPA3. We don't need to be scared of it. Because that was a perception I think set a little bit early on. But we see lots of client devices capable, especially the modern devices connected, capable of WPA3. Wi-Fi 7 gives us this 4K QAM, which is essentially putting more bits on the air. Right? This tighter constellation, we're transmitting more bits. It means that you need a higher quality signal. But we've done some testing where the client devices are actually able to maintain these higher MCS rates throughout the cell, which is really kind of nice. If you're deploying at a kind of a capacity-based design, we actually do see clients leveraging these rates in the APs as well. As I've mentioned, the easiest way to achieve higher throughput is to use wider channel bandwidth. We have 320 megahertz wide channels. You get one of them in Europe, you're probably not going to use this. Maybe in a home or point-to-point bridging, but it is something new on Wi-Fi 7. The preamble puncturing is another feature that I think has a lot of excitement around it, potential around it. This is the ability to work around interference. So let's say you have an 80 megahertz channel, and there's an interferer on one of the middle 20 megahertz channels. The system can automatically advertise in the beacon, hey, I'm not going to use this channel, you shouldn't use it either, and the clients will kind of work around that. How this actually looks in practice is, it kind of varies by the client, but yeah, on the Google, on the Pixel, as well as the the Windows client with the Qualcomm chip in it, they do actually work around that middle interference source. So the red is the active channel, and the green, the lower part in the middle here would be where the client is ignoring that 20 megahertz slice. The Intel client on Windows decided to just not use the second half of the channel. So we see different behaviors from different clients, but this is the technology working in practice. The most exciting feature in Wi-Fi 7 is multi-link operation. I think it's also the feature that we're still learning the most about in the field in real deployments, to be honest. So multi-link operation, there's two types of multi-link operation. One is this, basically link switching, so transmitting or receiving on one band at a time. And then there's the concurrent multi-link, where you're using multiple bands, so 2.4, 5 and 6, 5 and 6, simultaneously to to essentially improve your throughput. And the client devices are capable of different types of these different types, right? Some can only do the link switching. Some can do the link aggregation type. Most of the APs can do all of these, but it's the client devices that have the different capabilities. So how do you actually deploy Wi-Fi 7, Wi-Fi 6E? So there's I think 3 considerations. One is the security aspect. Right? So the first thing is you need to move to WPA3. So if your Wi-Fi network today is using WPA2, you should seriously consider how and start planning for WPA3, even if you don't have any plans to move to Wi-Fi 6E or Wi-Fi 7. The WPA2 is, at this point, a 20-year-old technology, and there's newer, more secure stuff out there. We have seen, many of our customers have successfully deployed WPA3. Just from experience, it's easiest to start with WPA3 Enterprise, because WPA3 Enterprise is very similar to WPA2 Enterprise. And then, next we see people start with the personal as well as guest, the open SSID. At the conference here, we're running OWE transition, which is both open and OWE simultaneously. That gets us 6 gigahertz, and that is has worked very well. I don't believe we've seen any reported client connection issues from not being able to connect with the OWE transition. The second aspect to consider is design. So with 6 gigahertz, you need a little bit more density generally, but if you already have a capacity-based design on your Wi-Fi network, then very likely you can do a one-for-one swap as you're refreshing through your generations. And then last is the network considerations. So there's 2 things in here. One is PoE, and one is the AP uplink connectivity. So from a power perspective, these APs, the Wi-Fi 7 APs with 3 radios, generally need more power, and oftentimes push above the 802.3 AT threshold. So, many of the APs need, 28, 29, 30, 31 watts, like just over AT, for full functionality. And all of our APs have reduced functionality modes on AT power should you need it. So, general recommendation from us is, yeah, if you're looking at a switch refresh, go ahead and refresh with BT power, 60 watt power, but it's not mandatory. You can very easily deploy, and many of our customers have successfully deployed Wi-Fi 6E, Wi-Fi 7 access points on PoE plus switches. Same thing from a multi-gigabit perspective, where we certainly prefer the APs, the newer APs, to be deployed on MGig capable ports, but it's also not mandatory. The last decade of Wi-Fi, we've been saying gigabit Wi-Fi is the moniker. We finally now actually achieve gigabit throughput in the real world, like outside the lab, but it's not something that happens every single day. So yeah, mgig preferred, but 1 gig is okay. So the point is, don't necessarily think that your wired infrastructure is not capable of supporting these newer access points. It very likely can. So the design guidance is, there's not a lot of difference between designing for 5 and 6 gig, but if you already have a capacity design, it's pretty easy. If you're more of a coverage-based design, you may want to consider augmenting additional 6 gigahertz APs. Here's some interesting data. I'm a data person, so I like looking at this stuff. I think one of the biggest benefits of 6 gigahertz is the ability to use wider channel widths. So in 5 gig, as we look across our customers, our most common channel bandwidth that's used is 20 megahertz. That makes sense. We have a lot of dense deployments. We want to minimize our co-channel interference. On the 6 gigahertz band, we actually see a difference in behavior between Europe and kind of outside of Europe. So outside of Europe, our most common bandwidth on 6 gig is 80 megahertz. These are in countries where we have the luxury of 1,200 megahertz of spectrum and can afford, in many cases, to use 80 megahertz. In Europe, however, the most common channel bandwidth is 40 megahertz on 6 gig, which is still more than what's used in 5 gig. So you see a throughput bump. For example, at the event here, we're using 20 megahertz on 5 gigahertz, 40 megahertz on 6 gigahertz in many places, and 80 megahertz in other places where we're able to. So yeah, it's just kind of interesting to me. From deployments, we have seen clients actually have a very strong affinity to 6 gigahertz. So if you have a 6 gig client, it's very likely to stay on to 6 gig using discovery mechanisms like reduced neighbor report and out-of-band discovery. And here's an example of a customer who had about 30,000 clients on their network at some point. And of those clients, almost 4,000, 3,000 were connected only on 6 gig. They never connected on 2.4 or 5. Right? It shows that, one worry that we had when 6 gig was released was, hey, there's so many channels here. Are clients actually going to be able to discover all these channels? And it turns out, yeah, it's a non-issue. The clients actually discover 6 gig just fine. Here is an example of the same event that's been held year after year, and tracking the 6 gig usage over those years. So the first year of this event was 2023, and all the numbers are blurred. That's not great. The kind of the net here is the first year, it was about 10% 6 gig usage. In the second year in 2024, it was about 20 to 25%. And then this year in 2025, the adoption was about 40%. So 40% of the overall usage was on 6 gig, and the amount of data that was transferred also increased dramatically as well. Here is a university customer, and this is looking at the capacity SLE and MIST, which measures how much headroom is there on the network. So this network, it's a large university customer. They have about 70 to 80,000 clients on the network. Their overall capacity SLE across all those clients was like in the low 90s, 92%, which is actually very good for deployment of that size. This is a year ago. So a year ago, over their winter break, they enabled 6 gigahertz. They first enabled WPA3, made sure nothing broke, and then turned on 6 gig. And as soon as they did that, 25% of their clients connected on 6 gig. And when the students came back after their winter holiday to start the spring semester, the capacity SLE had increased from the 92s to like 97%, right? So that's about a 5 percentage points increase, just by enabling 6 gig. and utilizing the additional capacity there, which was, I thought, really, really good and kind of speaks to the benefits of the 6 gigahertz band. In Wi-Fi 7, we also have some new deployment options in terms of APs with built-in directional antennas, which can be used for everyday type of use cases, especially in office environments. And then, that takes us to what's coming next, right? So what's coming next is Wi-Fi 8. The IEEE name is 802.11bn. It's also called ultra high reliability Wi-Fi. So it has a couple of features in here that kind of speak to reliability. I'll give this is something that is coming. Very much of it is subject to change. We're basically in the draft 1.0 phase in IEEE, but the expected ratification of 802.11bn is in the first half of 2028. So we're still a couple of years away. And the features are still being defined. So I'll go through a couple of the features that we're most excited about, and then there's a whole bunch of other features which may or may not actually become deployed. But probably the biggest feature that's being worked on right now is multi-AP coordination. This is something that moved out from Wi-Fi 7. This is the ability to coordinate between access points, coordinate transmissions and receptions to improve signal, reduce interference between clients, between the access points to a single client. So this has the potential to be very, very cool, very powerful, but also very complex. So there's a lot of details to still work out through this technology, and that will kind of come over the next couple of years. The second is seamless roaming. This is the idea of when you roam, can the APs coordinate better the roaming experience, right? So also referred to as make before break, right? So a secondary connection forms before it breaks the connection to the old, and to increase the reliability and decrease the time it takes for a client to actually roam. Today a fast roam might be 20 or 30 milliseconds. With this technology, it could get down to even single milliseconds. This is the big list of features that are being worked on in BN. Not all of these will make it. Not all of these will be useful. But to kind of put it up here of some of the other things to think about in a Wi-Fi 8 perspective. So with that, I will hand it over to Pavan to talk about cellular.
Thank you. So in the past few years, we usually just focused on Wi-Fi, but HP has been really pushing cellular communications within its products and its portfolios. So we decided to add cellular communications to this presentation as well. What we're going to do is just cover the basics of cell communication, talk about our 5G solution, and how that integrates into the future of networking. So at a very, very high level, the cellular networks, it's similar to Wi-Fi, but there's 7 main key components. One is you'll hear people say RANs. That's your radio access network. That could be your cell towers. You have a core. The core is just basically the heart of the network where you do authentication, routing, figuring out which cell towers to talk to. Transportation network, how do you talk to the different cells? Security, cellular is just as secure as Wi-Fi, but it has its own different security techniques involved. Subscriber management, of course, those of you who have SIM cards, eSIM cards, how that's all set up and how that's tied into security. Orchestration is just a way that you would grow your different size, your cells, depending on your users. And then you have service and applications, so your video, voice, streaming. So while I'm saying these components, they sound familiar. They probably sound like Wi-Fi, and if you compare them to Wi-Fi, it is almost the exact same thing. Your RANs, they're access points. Your core network is like your gateway. Transport networks, that's your fiber and Ethernet cables. So realistically, cellular communication, just like Wi-Fi communication, has to follow standards. Yes, we use different words, but theoretically, it's pretty much the exact same thing. Quickly go over some architectural things, because you've probably heard 4G, 5G, SA, NSA, and just want to give you a quick understanding of what that means. So 4G, think of that as an AP300 with a 7205 controller. So older technology, your access points, they have limited, range. They can operate in certain frequencies. And then your core network has IPsec, has some basic, encryption, but it allows communication between different people or different devices. Then when you go to 5G, there's two types of 5G. There's NSA and SA. NSA stands for non-standalone. Now what that means is you're going to use a 4G core and you would use the brand new 5G RANs. So again, that's probably like using an AP700 with a 7205 controller. You're using a bit of new and old, so you're getting the benefits of better signal performance, but you're still limited with security and features that you would get with your, because your core is still 4G. Then there's 5G SA, which is a full brand new 5G core and using a 5G RAN. So top of the line APs, top of the line controllers, like a 700s with a 9240. There you get brand new features. Of course, you get the better quality signal from the the RANs, but you get new encryption. You get slicing, which is a way of QoS, which with 5G NSA, you could actually have your network say, hey, this person here is playing video games on my cellular network. Let me give them more bandwidth. Let them give them better QoS. So it's a much more intelligent network. So that is what's coming in that's what's actually out right now. Some of your cell phones that might say 5G or 5G SA when you're connected to your network. That means that you're on a good network. The bands, just to understand what's going on here, is so in your 4G, 600 megahertz, about 4 gigahertz, you got about an average 20 megabits of data. 5G, there's two types of 5Gs. 99.5% of the 5G that you're using right now is sub 6, which means it's below 6 gigahertz. That's from 410 megahertz to below 6 gigahertz, and they're getting about 100 megs of data. So that's average data rate. Peak data rate's about a gig. Then there's a third option that's happening right now, and 5G is still in the early stages at the moment. We're still going to be pushing through. But 5G millimeter wavelength, that's where your frequency ranges from 24 gigs to about 53 gigs. And you're basically getting an average data rate of a gig per second. So when this comes out, your phone would be getting literally a gig downloads per second on there. Now, why don't we have it right now? It's just simple. The infrastructure is not there. I've seen at the Mobile World Congress where a pane of glass would break a signal. It's just not, the technology is not there, so we're still developing it. Things are happening. But it's really important to point out that 5G millimeter wavelength is the basis for 6G. So that will probably be coming out in about 10 years, but we need to figure out this millimeter wave infrastructure first. Okay, now moving to private 5G. So I had to say all of that in the first few slides to get to here. And what private 5G is, it's a dedicated standalone network. So what that means is whoever owns their own private 5G network, they have their own spectrum, they have their own security because you have to have your own subscribers. You can have different policies on the type of security you use. And the biggest feature is its ultra low latency. And of course, you can do localized control management. A lot of big examples are hospitals, factories that have devices that need to use ultra low latency. This is where we typically see them deployed. And then it comes down to what I was saying in the beginning, the future of networks. We don't, at HP, we don't see, hey, Wi-Fi is better than private 5G. We actually see it a different picture. We say that the two complement each other. So if you're in an event like today, and you have a mass attendance, a lot of people in there, you would not want to use private 5G on that situation. You have a heavy, dense crowd, Wi-Fi makes much more sense. But if you're in a long factory, say it's about 1 kilometer in width, and you have just machines running around at fast speeds, and they need ultra low latency, private 5G makes more sense. But then the workers in there who might be doing their day-to-day jobs, they probably want to connect to a Wi-Fi network. So we see the future is that private 5G and Wi-Fi will be used in locations together. Again, sorry, our vision is just a unified private 5G, wired, wireless, SD-WAN in a self-driving networks. So an example I could say would be a hospital. All your staff would be on their tablets or laptops. They'd be connected to your Wi-Fi. But then some of your pumps, some of your monitors that require ultra low latency, that don't want to be interfering with any of those Wi-Fi networks or any other kind of interference, they would go on the private 5G. And then at HP, we'll be managing everything, all the Wi-Fi, private 5G through our GreenLake platform. And we've done this already in the past. So you probably saw today in the keynote, there was a little blurb about the 2025 Riders Cup. Yeah, it's cool. We were able to do that. People were able to connect around there. But what you don't know is the actual setup on there. In order for people connecting, we had about 650 access points around there. But this is a big golf course. We didn't end up laying fiber across the green. We ended up having 3 different nodes of private 5Gs acting as a backhaul. This was able to have users connect and come back, and it would be just almost a seamless experience. We had even our 5G bridges in there to take some of those private 5G signals, convert them into Ethernet to go into our switches. And yeah, it was just an example of how the HP vision of private 5G and Wi-Fi is the future. So what's next? At the booth, we'll be doing demos over there at the demo booth. And the petting zoo, we have a lot of our Wi-Fi 7, our 5G products there. If you have more questions, Wes and I will be there. Many of our teammates will be there. We can definitely help you understand more about Wi-Fi 7, private 5Gs. We'll be happy to talk to you about that. Let's see here. Just the last few things. We encourage everybody to visit the Airheads community. If you haven't joined, you should really do it. Even for myself, who's more on the cellular side, when I have switching questions, they help me out. It's just an amazing community to join. So there we go. And then I just want to say really thank you. And your feedback really makes a difference. I said this is the 5th year we've done this course. Any kind of feedback would help us out. But I think on your app you can do that. Our session ID is TB1102. So that's about it. Thank you very much.